So I said before, numbers don't lie, but liars use numbers. It's just the way it is. The way you can use wordings and rearrange things to make it seem a certain way. One question you should always ask yourself is, was a sample used to gather the data unbiased? That leads into lots of different things. Most of the information that we get off of the television and out of magazines and whatnot is definitely not unbiased. Usually, to get truly unbiased, it'll be like some kind of scientific study. Was the sample of sufficient size? For example, you see that 2 out of 3 dentists say use Trident or something like that. This type of gum is good for your teeth or that kind of thing. Well, if it's truly they asked 3 dentists and 2 out of 3, then no, that's not big enough. But if that's a rounded answer, if they reduce that 2/3 from, 60 over 100, then that might be a little bit better. Although it still doesn't sound too good. And then number 3 is the statistical statement ambiguous. For example, a good example of that is like using the word large. We have the largest store in Northeast Arkansas, whoever it is. Well, what does large mean? Large is ambiguous. Large could mean square footage. Could mean actually size, which is kind of what they're implying. But large could also mean they're making the most money. Large as in their financial gains. Large might imply how many employees they have. Large just might mean the selection that they have. So if that's an ambiguous word. You don't exactly know what they're talking about. So you're going to be given like some paragraphs of information, and you have to look at it and see what could be wrong with it. So the statement that they give you is probably going to be, a statement that might make sense to you, but you have to think about why it might not be true. And these 3 things are a good place to start. Anybody have that? Okay. So charts and graphs can also be misleading or deceptive. Leave some space in there because we're going to draw some graphs so I can show you how they can do this. Okay, so for line graphs, obviously those are graphs that have lines in them. So it might look something like this. Say, these two graphs actually are based off of the same information. Just on the left, I changed the scale. I changed what I was counting by to make the graphs look differently. And people do this all the time. And it's not necessarily a lie. It's just can be misleading. So you have to know what you're looking for. You know, my husband was a salesman for years. So I'm not saying anything bad against salespeople at all. I just want you to go in knowing what you're looking for. So like, say you're going to buy a stock. If I want to show you how this stock has pretty much stayed the same over time and it would be great for a long-term investment, it doesn't have a lot of dips and whatnot, it doesn't change, I would probably show you this graph. And show you, see, look at this stock price, it's going to, stay about the same. So if you want to invest in it and you want to take your money out later, you're probably going to end up with, around the same amount. It's a safe investment. If I'm wanting to show you, hey, look how quickly this graph is growing, or this stock is growing, then I'm going to show you this graph. But these two are actually of the exact same stock. I've just changed the numbers on the side. And a lot of times, and be watchful of this, they'll show you graphs that don't even have any numbers. Well, how are you supposed to know anything from that? But they're just expecting you to trust them. So don't be naive. You ask those kinds of questions when somebody's sitting you down and trying to sell you something or show you something. All right. Same thing with bar graphs.